Hello Year 10, this is Lesson 8, the final lesson in the 1.4 booklet on domestic electricity. So, exam style questions. You can have a go at these on your own first and then check the answers afterwards. That's what I would be doing, just to see what your knowledge base is like. Now, this questionnaire, the following label is attached to the back of a microwave. Always read the question. A microwave oven. And it also contains an electric grill. I can see here the voltage, 230 volts. I can see here that the frequency is 50 hertz. It's mains electricity. We can also see that the microwave power is 1.2 kilowatts and the electric grill is slightly more powerful at 1.8 kilowatts. Now we get to answer the question. The mains electricity supply in the home is 230 volts. The answer's in the question. And it has a frequency of 50. But you've got to put in the units here. You were given the units for the volts, but here you need to put it in, and it is big H, capital H, little z, means hertz. The power of the grill power, look out, you've got the answer in kilowatts here, it wants it in watts. To convert kilowatts into watts, you times a number by 1,000. 1.8 times 1,000 is 1,800 watts. Now, before I move on with the rest of these questions, I'm going to go back because there's some extra questions that aren't in your book, but they're useful to go through, okay? A fuse can be used to protect an electrical circuit. Name a different device that can also be used to protect an electrical circuit. We've got our miniature circuit breakers, or our residual current circuit breakers, used to protect circuits from too much current. Now, we've got radio, and the radio can be powered by connecting the 2-core cable. What must be fitted to the cable before it can be connected to the mains electricity? A 3-pin plug. It only has 2 wires inside this cable. What are the names of these 2 wires? It is the live and the neutral. There is no earth wire in this radio. Why is there no earth wire? It is because the radio itself is made of plastic. You only need an earth wire if the appliance is metal. So, it is safe to connect the radio to the mains electricity supply using the 2-core cable because the radio is double insulated. In other words, we've got a piece of plastic here and the cables are surrounded by plastic as well. It is double insulated. The radio can also be powered by a battery. Now, a battery provides DC, direct current. DC only. But I'm going to leave it at that. It's nice and simple, that one. So let us move on. The grill and microwave are used continuously to cook a small joint of meat write down the total power. Well, it's going to be 1.2 add 1.8 gives us 3. Don't forget the units. Small k, kilo, big W for watts. Now, the cooking time is 0.5 hours. That's half an hour. That's 30 minutes, right? We're going to use this equation to calculate the number of units of electricity used. So that equals the power in kilowatts, which is 3. We've just worked that out. Multiply that by the time, half an hour. And that gives us 1.5. Now, units for electricity are measured in kilowatt hours. Now, question 3. Each kilowatt hour of electricity costs 14p. So the cost is the number of units used, which was 1.5. Multiply that by the cost for 1 unit, 14p, gives us 21 pence. And that equals that value in pounds. Exactly the same. Solar panels are fitted to a house. They save money for the householder in 2 different ways. Number 1, they reduce the number of units of electricity bought from the national grid, saving 16p. But added to that, the government pays the householder a feed-in tariff of 14p. So, question 1, what is the householder's total saving for each unit used from the solar panel? You're saving 16p because you're not buying it for the national grid, but you're also being given 14p by the government for every unit that you've generated. Add those two together and you get 30p. Now, question 2. Each year, the householder uses 4,000 units of electricity generated by the solar panels. Calculate the total savings in a year. Well, we've given the equation total savings per year is the total savings per unit. That's our 30p. And multiply that by the number of units. That will be 4,000. And in pence, that gives us a grand total of 120,000 pence. Now, to get that into pounds, divide that value by 100 and you will get £1,200. Solar panels produce electricity for 2,000 hours per year on average, right? Calculate the mean power output of the solar panels. Well, how many so the power equals the units used divided by the time. Well, we used 4,000 units. Where did I get that from? Let's just go back for a second. There it is. 4,000 units. That's how much they use. And you divide that by the number of hours that the solar panels produce electricity. That's 2,000 hours. And that gives us a power rating of 2. There's the units, kilowatts. And number B now. it is estimated that fitting solar panels reduces CO2, that's carbon dioxide emissions, by 0.7 kilograms for every unit of electricity produced. Calculate how much CO2, carbon dioxide, will be saved by this household each year. Well, they used 4,000 units of electricity that was generated by solar panels. That saves 4,000 times 0.7 kilograms, and the total amount of CO2 saved, because they were generating their electricity through solar panels, which don't release any carbon dioxide into the atmosphere, unlike coal or oil or gas. So you're reducing your carbon footprint by 2,800 kilograms. We've got a mains lighting box. There's some lamps and there's some switches. Question A. Question A. For safety reasons, the fuse and switches, they're always placed on the live wire. Always. Now, for a lamp to light, there must be a complete circuit. With the lamps, state which lamps are lit when S1, switch S1 and S2 are closed. So closed. S3 will be open. So that means lamps A and B will be lit up. So A and B. State which lamps are lit when S3 is closed. S3 is closed here, but S1 and S2 are open. Well, that therefore means that the only lamp that will be lit up will be C. We've got a ring main circuit used in the home. A power point socket is shown correctly wired. That's that one there. This one up here. B represents another switched power point. That's that one down here, and we're going to link that 3-point plug into the ring main circuit in a second. Now, give a reason why X must be a live wire. It's got an MCB or fuse attached to it. An appliance is safely connected to one of these power points. Compare the currents at point X and Y. They will be the same. Now what I haven't done is I haven't completed this part of the question. It's good that you must read the question, otherwise you'll muck it up. Now, we know that the switch must go to the live wire, and we can see that the live wire is this one here because it's linked in with the MCB or fuse. So this will travel to here. The earth wire, the dotted line, goes to the top pin in a 3-pin plug. And so our neutral wire must go to the same wire as Y. Now, B. The metal body of all electrical appliances should be connected to the earth wire. Yes. Explain how this gives protection to the user of the appliance. I'm going to make this a little bit bigger. Maybe a little bit smaller now. Okay, I'm going to try and write this in here. If the outer metal body of an appliance, you know, like a kettle or a toaster, conducts electricity, well, that's clearly dangerous, yes? Because if you were to put your hand on that, the current could flow through you. This is dangerous. However, if the outer metal body conducts electricity, current flows through the earth wire. This causes more current to flow through the live wire, causing the fuse to melt, or if it's attached to an MCB, miniature circuit breaker, for that to trip. This stops current flowing and gives protection to the user of the appliance. Okay, well done today. Thank you.